The modern industrial landscape isn't a monolith. Data processing often happens in a million different places, and getting those systems to actually connect and talk is often a daunting task. Hey there, my name is Christopher Sandoval. I'm a developer relations advocate here at FlowFuse. And today we're going to talk about how to solve this critical problem. We'll dive into the realities of routing data between the cloud and the edge. And we'll look at why this is critical for your business, for your services, and for your workflow. All right, let's dive right in. The realities of industrial data. Now, if you walk into any modern factory, you're going to be quickly inundated with signals. You have PLCs speaking OPC UA, sensors publishing to MQTT, legacy systems that are pushing outdated protocols into cutting-edge frameworks. And while the data layer might seem universal to people outside of the stack, the reality is that it seldom is. Beyond connecting these devices, historically, getting them to actually share data was super messy. It required custom firmware, bespoke solutions, and point-to-point integrations. And these solutions were often a stopgap, not an actual fix to the problem. And while we've moved towards less proprietary connections and less bespoke integrations to make these systems work, we still tend to struggle with the transit layer of this data. And it's not even just a technical problem at this point. It's one of architectural understanding and application. The conflict between edge and cloud. So while it's cool that all these systems are finally generating data that we can see and remix, we have to keep in mind that that is relatively recent. And so a lot of the architectural and design decisions that you may have made in the 80s or 90s just won't fly today. And in a lot of ways, that's only half the problem. The other problem is that we have a mixture of devices that are no longer just in the same factory working with the same data. We now have systems that could be at the edge, at a central processing site, or thousands of miles away in a completely different country. And that introduces a lot of friction and complexity. On the one hand, you have edge devices that are generating all of this data, and you would love to do all of your processing right then and there, but the fact is that most of those edge devices are pretty low powered. And even if they're not low powered, then they start becoming really expensive to roll out across the entire edge locality. Okay, great, we can push it all to the cloud, right? Well, then you start introducing problems with latency, vendor dependency, and all sorts of other tack-on negative effects. So in most factories, this is the typical story. You're creating a bunch of data via machines that can't really handle or process it, and you're pushing it out to cloud systems that are often really far removed from the process of the creation and the structuring of the data itself. And that is why data routing is so important. Getting this right means that you will reap all the benefits of cloud storage and compute while maintaining local control and locality to your data. Okay, so that's the problem. Now, how do we solve it? Bring processing closer to the data. So the first thing that you can do is to bring processing as close to the data as possible. While it's true that most edge devices aren't going to have the compute or storage power to do everything that you want, you can still move the resources that do have that capability closer to the data. In practice, what this usually looks like is finding the next terminal point from your local data where you can actually integrate that data into processing. As an example, we recently showcased this at Prove It 2026. In our demonstration, we had a set of really complex database calls. Now, we chose to store the database on the next layer up in the ISA stack. And a big reason for this was that the data that was being generated from devices that just didn't have a ton of computational power. So by generating that data and then storing it in a common store that was the next step up, we could ensure that the calls for that data were being processed as local to that data as we possibly could. And that allowed us to significantly reduce latency and correct the drift that is inherent with remote data calls of this nature. This data was then surfaced through MQTT to a cloud layer for more complex processing. And because that transit layer was hyper efficient, we were effectively able to bridge the gap between the edge and the cloud services as if they were both local to one another, without impacting where the data was being stored, how the data was being acted upon, or what you could actually do with the data once it was processed. But this kind of solution isn't always possible. So what do you do when your remote data is fully isolated from your cloud data? Send data out for central processing. So when you have to make the jump out from local-only data states, your best bet is going to be sending either the data or a representation of the data itself out to some other central processing and storage store. Now, this kind of approach is best used for data that isn't frequently changing or is representative of a state. For instance, imagine you have a production line that depends on a certain number of shipments coming in every day. Now, you may have those shipments coming in every hour. It's not like you're having those shipments coming in every single second, but you still need live reporting of the state of those shipments and what's still to come and how many units you've actually received compared to what you were expecting. So for this kind of problem, the best idea is actually to create a state that represents the overall state of the data resource itself. Instead of reporting all of the shipment details about the trucks that are coming in and who's driving them and whether or not they're carrying the load that they said they were going to carry, instead just create a singular resource that you can push out. Have a representation of this shipment and what was expected on a cloud resource. And on the local resource, just scan something like the license plate. When that license plate comes in, you can push an update to a Boolean flag that says either true or false if they're inside the premises of the factory. And then on the weigh station, you can have another device that measures the weight of the cargo. And when the driver comes into the complex and scans their ID to get access, you can take that information from that edge device and push it to a central server as well. And once you have all of this data in a central location, then you can make your complete data package, and then you can push that complete data package to the cloud for additional processing or to local resources for better contextual understanding, inference, and insights. So what you've done here is take all of your edge devices and kind of make it function like a brain. The idea here is that if each edge node isn't powerful enough to handle the whole, then split the task into parts and have them each handle a specific segment. Consider cloud compute and remote architectures. And that solution actually raises a pretty interesting point. See, often the best route isn't actually the one that you think. You may think that you have to push all of this data over MQTT. You may think that you have to update a centralized database constantly. You may depend on intraflow routing or project in and out nodes. But the simple fact is that oftentimes sidestepping complexity can get you greater gains than if you were to do something a little bit more fancy. For instance, if you have a sensor that does something like capturing an image in base64, in theory you could capture that image and then do local computer vision and processing. But what are you actually using that image for? Do you need real-time processing then and there? Or are you using the processing of that image as a sort of gate? You're saying, yes, this license plate was scanned and this person is in the system. Well, in that case, it might make sense to do this completely differently. You may need local processing of the image right here and now, and you may also need processing for the future, but you don't have to handle that in the same place. You can send the image to be stored in a database. Then you can take that image and push it to a cloud resource. You can tie it to something like an ID badge scan. If the person scanned their ID, the ID scan gets them inside the building, and the cloud computation on the image itself detects exactly who they were, and then you can process the image in the cloud to make sure that the license plate is exactly what you expected it to be. And then over time, if you ever had to do forensic auditing, well then you can go back to the database. So in this way, you've taken something that could have been really complex, something that required a lot of local computation and database storage, and you've instead distributed it in a way that makes more sense. You've essentially separated inference from storage. And although the inkling might be that, hey, we're collecting this data here, let's do the processing here, depending on your scenario, the best way to handle that may not be that archetype. It may instead be something more hybrid. And the inverse can be true. Instead of using a really complex edge model to do computer vision, why don't you implement a low-power NFC solution? And then use the images that you're capturing to compute vision to handle quality in the cloud. All of a sudden, the way you think about the problem can be drastically shifted. And that shift could save you tons of time, money, and headaches. If you're still thinking about data routing as a protocol routing problem, you're missing the big picture. And that's where FlowFuse becomes a really powerful solution. FlowFuse decouples connectivity logic from application logic. By allowing you to take any data source and turn it into something that can be connected and remixed, you can fundamentally reconsider exactly what you're collecting, why you're collecting it, and what utility it actually serves. FlowFuse has 1,000 ways to do the same problem. And what that means for you, the end user, is total freedom. So as you're moving forward trying to figure out exactly how to handle your data routing, I want you to ask one question. Does it really need to be handled in the way I think it needs to be handled? Or can we get creative, flexible, and more powerful? The simple fact is that routing traffic in FlowFuse isn't about moving data from point A to point B. It's about designing a system that works for your particular implementation. One that gives the edge autonomy, the cloud visibility, and your entire stack dependability. If this sounds like a problem you're familiar with, I definitely suggest you go check out the Road to Prove It video series. We did a ton of unique data routing within that project. You should also check out our article knowledge base that shows you how to connect pretty much anything to pretty much everything. And finally, if this piqued your interest in FlowFuse, head on over to flowfuse.com for your free 14-day trial. This has been Christopher Sandoval. Thanks for watching, and I'll see you next time.